Math for me is a very abstract subject. Learning usually happens best when I can relate to real life. As math becomes more advanced and challenging, it can be difficult to do. My name is Emma Sneak. I'm a grade 11 student taking grade 12 advanced functions, and today I'm going to present you with my CCT question. In this unit of the grade 12 math curriculum, we will be taking a deeper look into how to solve polynomial equations. These concepts will include factoring, establishing odd and even symmetry, understanding exponents, and graphing. The question we will be analyzing is as follows. The distance of a ship from its harbor is modeled by the function y equals negative 3t cubed plus 3t squared plus 18t, where t is the elapsed time in hours since departure from the harbor. Starting with question A, we are asked to factor the time function. So where exactly do we start? If we are looking to factor, we want to find a factor in the equation that is common in each term. So in this case, I recognize negative 3t is present in each of the different terms. When we factor the negative 3t out, we are basically going to be dividing it by each term. So for example, we are going to be doing negative 3t cubed divided by negative 3t. 3t squared divided by negative 3t. 18t divided by negative 3t. We aren't done just yet. We now have a quadratic equation inside the brackets. T squared minus t minus 6. We're going to label it A, B, and C. To get to the factors, we want to multiply A times C, and with those factors, they should add to B. So for A, we can do t times t, which equals t squared, and for C, we can do negative 3 times 2 equals 6. At that same time, we know that negative 3 times 2 is 6, but it also is negative 3 plus 2 is negative 1, which is our B factor. So we can line those up into a factored form. So now we know that our time function is negative 3t, bracket t minus 3, bracket t plus 2, bracket. For question B, it's going to ask us when does the ship return to the harbor? So we're going to want to look for the main points that we're able to establish from looking at this equation. We are able to tell and verify that it is a cubic function. I am able to see this because its first term, negative 3t cubed, is to the power of 3, and that's going to tell us it's a cubic function. At the same time, we're going to have to establish if it's even or odd symmetry. If it's negative, it's going to be odd, so negative 3t cubed is negative, so we know it's going to be odd. That is key information for knowing how to graph my polynomial equation. But when trying to figure out when the ship returns to the harbor, I'm going to look at my factored equation and see that my two terms are t minus 3 and t plus 2. We're going to set t minus 3 equal to 0, so then t equals 3, and we're going to set t plus 2 equal to 0, so it will be t minus 2. At this point, I know that the ship is going to return to the harbor after 3 hours because it can't be 2 because it's negative. This is going to lead us into our next question, saying that there's another 0 of this function. What is it and why is it not relevant to the problem? Well, as I said before, time can't be known to be negative. For example, it can't be negative 2 o'clock p.m. So graphed on our function, we're able to tell that it's going to return back to the harbor after 3 hours, not making negative 2 relevant to this situation. Moving on to question D, it is going to ask us to draw a sketch of the function where t is between and equal to 0 and 3. This question is pretty straightforward. All you have to do is forget about all the other parts on the graph except for the curve that goes from 0 all the way up and over down to 3. And that's where the graph will stop for this question. And now for question 3, we are going to be asked to estimate the time that the ship begins its return trip back to the harbor. So this is an estimation, so we can do that by just looking at our visual graph. We can look between 0 and 3, right where the middle curve is, right where it goes and makes the turn back from 0 up and down to 3, where that point is. So looking at my scale of 0 to 3, I'm going to guess approximately it's going to make the turn at 1.5 or 1.8. Something around then is when I believe it's going to make its turn back to the harbor. So now you might be wondering, why on earth am I wanting to know this? Well, there are many similar careers that need to know this type of function, how it works, and why it's important. Pilots and aerospace engineers use these functions to find the displacement of an object under the influence of gravity. It helps them measure characteristics such as force, mass, and acceleration. This helps them graph their course, takeoff, and descent power.